All right, so like I said earlier, yesterday was kind of the idea of, here's a reminder on inequalities. When we switch the inequality symbol, we looked at compound inequalities a little bit, and then we introduced interval notation yesterday. That was kind of the newest thing that we were looking at. Today we're going to apply that now specifically to absolute value inequalities. Okay? So that's what we're going to take a look at to begin with. So, absolute value. First part, just a reminder that here's kind of technically the mathematical definition. What this is really saying, if I interpret this for you, is remember that absolute value is a distance from zero on a number line. So there's always two possibilities. Okay, so if I say 7, for example, both 7 and negative 7 are 7 units away from 0. Okay, that's really what this is saying. Which is why, last week when we did absolute value equations, you ended up with 2 equations, 2 answers, because of that reasoning. Distance from 0. Okay? Now, with that being said, and you don't necessarily need to write this down, this is just a reminder. But with that being said, here's the process I'm going to have you work your way through. There's multiple ways to do this. I picked this process in particular because we can use it again going forward with other types of functions. So I didn't want to give you something that's only works with absolute value, and then we got to switch to something else. I was trying to give you something that would work going forward with multiple things. So first off, when we're solving an absolute value inequality, turn it into an equation and solve it. Find your critical points. Okay? Find the critical points. Ignore the inequality at the beginning. What that allows you to do then is when you're solving, you don't have to worry about, do I switch the inequality symbol? Do I have to switch it now? Do I switch it back? It eliminates some of that out of there. So turn it into an equation and solve. And I've got a couple examples we'll take a look at. Then you're going to take that and you're going to graph those critical points on a number line. Okay? Just like we did yesterday. You don't have to worry about shading at this point. But the critical points then will take your number line and split it into parts. If there's only one critical point, it'll split it into 2 parts. Less than that value and greater than that value. If there's 2 critical points, it'll split it into 3 parts. Okay, which you'll see if there was 3 critical points, it splits it into 4 parts. And the idea then is once you have that, you then are going to test. You're going to test those different regions for true or falseness. Okay? Meaning, back up in the original inequality, you're going to test different values and plug them back in and see, do I end up with a true statement in each region or is it false? You're going to look for true or false regions. And then finally, once you figure out, all right, here's the part of the graph that actually, here are the answers right here. Then you're going to write your answer using interval notation, your final answer in interval. Two and 3 kind of go together. You're pretty much solving the equation, testing the different regions on your number line, and then writing your final answer in interval notation. So 2 and 3 kind of go together. And you'll see that, like I said, in the examples that we take a look at. All right, so let's take a look. So first example then. Here's your first example of an absolute value inequality. Okay, a basic one to try to get the concept, and then we'll go a little bit more difficult, but not too bad. So the number one thing I'm going to tell you when you're solving an absolute value inequality, and I'll repeat this on the next example as well, is just like when you solved radicals, you had to isolate the radical first. You had to get it all by itself. Anything outside we had to get rid of that. Same thing with absolute values. Okay? Now, this one, there's nothing outside, so we don't have to worry about it. But if there was something in front, or let's say there was something added or subtracted, if this was over 5, for example, you'd have to get rid of that stuff. Solve for the absolute value, then start the process. Okay? So step number 1, we said, ignore the inequality, and let's look at this as from an equation standpoint. Absolute value, remember, is distance. We want this to equal the numbers that are 4 units away from 0 on the number line, which means equation number 1 is x minus 20 equals 4. And what's equation number 2? Negative 4. Okay? You got to set it equal to the numbers that are, in this case, 4 units away from 0. So x minus 20 equal to negative 4. And now we solve separately. Okay? Well, now we're finding our critical points that we're going to put on the number line. Add the 20 over. We get 24 from the first equation. Add the 20 over, and we end up with 16 from the second equation. Okay. There's your critical values. And I say critical points, here's why. Let's say I plug 16 back in. 16 minus 20 is negative 4. Absolute value of negative 4 is 4. Is 4 greater than or equal to 4? Yeah. So these are the points where they're equal to 4. These are the 2 points where it's equal. Now we got to add in the inequality part of things. Okay, so let's put the number line down. And in this case, I know yesterday I told you to put 0 on there. I'm going to tell you not to put 0 on today. Okay, just put the critical points down. So let's say that 16 is right here. Let's say that 24 is right there. And that breaks our number line up into 3 sections. Anything less than 16, between 16 and 24, and anything greater than 24. Those are the regions we need to test. So we're going to test it. We'll just plug it right back into the original. Any value you can pick. Let's say I pick 10. I plug it in. 10 minus 20 is negative 10. Absolute value of that is 10. Is 10 greater than or equal to 4? Yep. I'm going to put a little t right here. True. That's going to be part of my answer. Okay? Any value that's less than 16 will form a true statement when you plug it back in. Doesn't matter whether I pick 15, doesn't matter whether I pick negative 50, anything will make that work. Pick something in the middle. Let's say we pick 20. Plug it in. I get 0. Absolute value of 0 is 0. 0 greater than or equal to 4? Nope. Therefore, false. I'm going to put an F right there, false. That is not going to be part of my final answer. Okay? We're looking for only regions where we end up with true statements with the inequality. And finally, last region, anything greater than 24. Okay? The other class said 25. Let's pick 25. Plug it in. You get 5. Absolute value is still 5. Greater than or equal to 4. True statement. So we actually have 2 regions here that are going to be part of my answer. And now we write it in interval notation. We write our final answer and put the intervals down. Let's start with the first interval. Remember, we always go left to right. What's the first thing I'm going to write down if we're going from left to right? Now, over here to the left, if this keeps going forever and ever and ever in the negative direction, we're at negative infinity. Remember, we put a parenthesis there because we can't include infinity or negative infinity. Up to what? Up to 16. That's where it switches from true statements to false. That's our critical point. So up to 16, and here's the question. Bracket or parenthesis? How do you know, Cooper? Greater than or equal to, which means if I plugged 16 in, which we did earlier, it does actually form a true statement. So we have to include 16. There's the bracket. Now, we're kind of skipping over the middle part, but now there's a second portion that has to come into play. So if you remember yesterday, we talked about the and versus the or type of inequalities. This is one of those or type of inequalities. The 2 ends of the number line versus the middle. So, mathematical symbol for or, we put a U, meaning there's one set of numbers, or, and now we describe the second interval that works, which is here, starting at 24, bracket or parenthesis? Bracket for the same reason, okay? We're including 24, and we're going to go to what? It'll go to infinity, okay? Keeps going forever in the positive direction. Anything bigger than 24 will work. And there's your final answer to the problem right there. Okay. This is one of those or type of problems because we have two, like I said, the two intervals. Let me stop for a second. Anybody have any questions? Anything up here not make sense in terms of why I did something? Okay, let me give you one more. We'll make it a little bit more difficult, but not much. So on this one, what do you think we do first? Yeah, remember we said we have to isolate. I cannot, and I'm going to bring this up because it happened in the other class. I mentioned it, same thing. We cannot immediately go directly to, equal to 9 or negative 9. That only works when we've got to get the absolute value by itself. Then we're talking about distance from 0. But not until the absolute value is by itself. So step number 1 here is we have to divide both sides by 3. Now we've got an absolute value, and now it's basically the exact same. You're in the same spot we were on the last one. So let me give you a couple of minutes. I'm going to give you 2 or 3 minutes here. Try this one. I know you've only got one example, but use it. Okay? Put your equations down now. Solve them. Find your different regions on the number line, and test them out. See what you can come up with for a final answer. You should get some fractions. If you're getting fractions for your critical points, you're doing it correctly. take a look and see how you did. First off, I did the first part. We got it less than or equal to 3. Absolute value is by itself, so therefore we're looking at which numbers are 3 units away from 0. So we set it equal to 3 and negative 3, solved each one separately, end up with 1/5 and 7/5. As I was walking around, I think everybody got that. So we were good there. So now we need to test things out, okay? And you could test it out right here. It's probably the easiest place to. If you really want to, you could go back up to the beginning and you could test it out in the beginning too. It's a little bit more complicated, so I would probably go to that point right there. Okay? So anything less than 1/5. For example, let's take 0. Let's plug it in. If I take 0, I get 0 in this. Negative 5 times 0 is nothing. So we end up with 4. Absolute value of that is 4. Is 4 less than or equal to 3? Nope. This is false. Therefore, that is not going to be part of our final answer. Then we move to the middle. Any number. We're just going to test something between 1/5 and 7/5. Okay? Let's pick 1. If we plug 1 in, I get a negative 5. 4 minus 5 is negative 1. Absolute value of negative 1, remember, is 1. Okay, you're 1 unit away from 0. Is 1 less than or equal to 3? It is. Therefore, the numbers in the middle region will work. Okay, any number. I picked a nice one. Anything in that middle region will work out. And finally, we pick something bigger than 7/5, whether it's 2, whether it's 5, whether it's 10, whether it's 100, doesn't matter. Let's pick 10. We'll plug it in. We get 4 minus 50, so we get a negative 46. Absolute value is a positive 46, which is definitely not less than or equal to 3. So therefore, also false. That first example, I said that was kind of like your OR type of problem, where it's the two ends. This one's kind of like an AND type of problem. It's that compound AND inequality because it's the middle. Bigger than one number and at the same time less than the other. So now if we write our final answer, we put our interval notation down. We're going from 1/5 to 7/5. Those are the only answers that will work. And brackets or parentheses? Parentheses? Yes, agreed? Based on the inequality symbol? Please disagree. Okay? Less than or equal to. Or equal to. If I plug in 1/5, I will get 3. If I plug in 7/5, I will get 3. And that is equal to 3. Therefore, those values, those critical points are included because of the equal to part. So in this case, we're going to actually have brackets. And there's your final answer right there. 1/5 to 7/5, anything in between, including those values. The only way, and this is the last example I have for you, but the only way that this could be any more difficult than what we're doing now is by just continually adding stuff outside of the absolute value. If there was something added, if there was something subtracted, divided, where you have to do more work to get the absolute value by itself first. Otherwise, this is your process. Okay? And like I said, the good news is this same type of process will work on the next lesson as well. That's kind of why I did it this way, like I said. Okay? Or at least kind of work on the next lesson. So what I have for you today is your next worksheet. You got an absolute value inequalities. There's 20 questions. The first 10 are all absolute value. The second 10 go back in a little bit of review of the compound ones that we were working on yesterday. Okay? And I'm going to give you the rest of the time to work. So you've got a decent amount of time to work. As always, show your work. I will give you a little bit of time, like I said, maybe the first half of class tomorrow. If you've got some questions you want to go over, we can go over that. Otherwise, you'll have a little bit of time to wrap some things up. And then I think we're going to move into the next and final lesson of this chapter. Okay? Let me hand this out, and you can start working.